It's actually Samsung. Sorry. So I mean, basically, there's about 5 reasons that everybody knows why your oven won't heat. Okay, I could have a power gas supply that's not on. I have could be set in demo mode. Could be a blown high limit fuse. Could be a bake element faulty, the igniter not pulling the correct amperage. Could be that we have a bad board. I have one here. I'm at my father's house helping my father who just had just tore his Achilles tendon. So I'm down here helping him, and his oven in the lower one has a bad board. So that's something that I'm going to have to deal with. Then I have could be that the unit is stuck in clean mode. So does anybody else think they have another reason? If you have a reason, please put it in there, and let's talk about it before we get too far into everything. Okay. Doesn't look like anybody else is going to write in. So let's just say this, guys. If you have a comment, right down there it says post a comment in the bottom right hand side. That's just go ahead and put your comment in there. So how important is a wiring diagram? I would tell you that until you get super good with an oven, and you've seen so many of them that you can actually just go in and it becomes second nature to you, you've got to have a schematic. Okay. I would not ever try to repair an oven without a wiring schematic. You never know what they have changed in an oven, even though you've done it 100 times. You never know when somebody at the factory, one of the engineers, has changed one little thing on the oven, and it could be your whole problem. So you actually need a wiring schematic to be able to read what you should be reading for the oven. Okay, so this is basically an oven schematic for a door lock switch. Okay, so if I'm putting this oven into excuse me, if I'm putting this oven into a self-clean mode, I have to have the door lock switch, and this whole series has to be closed for the elements to come on. Okay, everybody knows that that an oven, if you put it in self-clean, you're gonna have a temperature somewhere, depending on how old the oven is and who the manufacturer is, can go up to about 1200 degrees. Okay, so wiring diagrams. All right, here is your Samsung oven wiring diagram. Okay, and this is for the FM board. We're going to get through, and we're going to go through and look at other wiring diagrams. So make sure that if you want to go back and you want to review this training, that you have the Encompass Training app on your phone, and then you can go back and look at it at any time that you want to look at it. Okay, so this really doesn't tell you anything. If you look, there's numbers at the top. So what happens is I had to split this in half because I couldn't get it all onto one slide. So, I didn't realize that was as small as that is. But it will tell you, okay? So it tells you what the part number is, okay? And it tells you what the part name is. So number 1 is the RY201. So what we do is we come back over here, and if you look at 1, it's down here in the bottom, and that tells you that that's the RY201 relay. Okay? So that's the reason I say you probably want to do this, okay? Here's your broil terminal. I'll spit it out in a minute. That is 15 and 16. So if we come back over here and we go to 15 and 16, well, of course, it's right there. There's the 16 relay. Okay. There's the 15 and the 16 relay at the top to the on the two from the left and two from the third from the right, left. So that is your broil relay. Okay. Then if you wanted to go on down, you can just trace this down. And the nice thing about Samsung is they do give you the part number. Okay. You may not be able to replace just that part, but if you're an electronics technician and you're very familiar and you can replace the little relays, this is very good to have. Okay, right here you can see it only goes up to 10 here. All right, so but it's the same thing, and this is a different board. Okay, so this tells you that it's the main communication connector. That number one. Number two is a lower oven knob backlight connector. So if you look right here, go back to it. There's number two right there. It's at the top left. Number one is that it looks like a Molenex plug right there. Okay, so this will tell you exactly where everything is. Now, these are really not wiring schematics. This is the wiring schematic. Okay, the other is more like a part schematic. So if you look at this, you can see that L1, okay, goes. If you look at it, first thing it broil element, and then it goes across to the element heater, which is the actual element. And then you pick your L2 side up from the right side. If you look, there is a thermostat that will open for all of these. So if I have a bad high limit thermostat, I won't get any power on the L2 side to my bake, my broil, my any of those. Those all are controlled by this high limit thermostat. Okay. So right here is the bottom half of that. Like I said, I had to cut it and splice it just so that everybody could see what it is. And you can actually do this by just folding the paper up and finding out where you want it. You know, you can crease it and put it up. Now comes the next question. I'm going to go back down to here to exit full screen. Okay, so guys, I have a question. Where is this located? As long as nobody has been in it and messed around and taken the wiring schematic, and I will tell you that it is nothing worse than trying to get out there. Whenever you get out there, Mike, what do you talk about? Is this working? I'm going to give you a second answer to that. I'm going to go back to what I was talking about. There's no reason that you can't. In every manufacturer usually has either a sticker, like my dad's oven is an Electrolux oven, and his has a sticker on the very top of the oven. Some of them have a little pouch that is inside the cavity. You have to take off about 6 or 8 screws to be able to get to the pouch. The pouch you pull the wiring schematic out of the pouch, and that's where you're going to find your wiring schematics. Okay. Also on that wiring schematic, usually down on the very bottom, okay, it will tell you resistors, what your resistor should read. Okay, that's on the very bottom of that wiring schematic. Okay, does anybody have any questions before we move on? we only have an hour, and I want to try to get through. This program is going to be at least an hour. Maybe we may run a little bit over. So does anybody have any questions? I'm going to give you another second to type it into the comment. Okay, let's go ahead and move on. Okay, so right here it tells you that the broil element is your input's 240 volts. What kind of wattage are you getting on your broil element? You're getting 440 watts. Okay. Does everybody, if you've been on in any of my classes where we've dealt with reading wiring schematics and basic diagrams, we have gone over how to get wattage whenever you have ohms and voltage. Okay. So if you don't know the answer of how I get wattage, you need to go back to basic wiring schematics, and I go through how to determine what how to get a wattage. Okay, so we've got your broil element. Okay, your broil element is 440 watts. Your bake element is 3,000 watts. So it's a whole lot. It's another 1,400 watts less. Your convection heater is 1,300 watts. That's all. That's what goes around your convection oven. This unit has a steam heater. And the steam heater has 500 watts. Okay, that's on the top upper oven. The lower oven has no steam heater. Okay, so you only get steam on the upper oven. Okay, if I'm looking at the elements in the bottom oven, I have the same basic wattage as I have for the upper oven. The only thing like I said is you do not have a steam heater in the back in the bottom of it. Okay, so here is the lower oven schematic. Okay, you can see that you have your bake, your broil switch, your convection switch. Those all go through the L1 side, and then you pick up the L2 slide as long as the high limit is closed. You get your L2 side. What I'm telling you is, if I have a blown high limit switch, I'm only going to get 110 volts. Okay, there is no neutral. It's only an L2. The one thing I don't like about Samsung is they don't have the little wavy line that tells you that it's not connected. So if you look at this wiring schematic at the very top, the neutral, it looks like it goes right through the L2, which it doesn't. It actually jumps over the L2. Okay, does anybody, here's the bottom side of this. This is where it's connected to the upper oven. I think this is what's the matter with my dad's. I haven't pulled it. I'm going to have somebody to give me a hand, because his actually has convection and steam, and the oven weighs about 350 pounds, I think is what it is. And I'm not going to bring it out. And it's, of course, this is a double oven, so it's about a foot off the ground. So I don't want to take and put it on something, because I don't have an oven dolly with me. I would tell you that if you don't have an oven dolly, it's very difficult to do an oven properly. The problem with setting it on a toolbox, or I've seen guys that set it on like a cinder block. you run the risk of once again damaging the floor of the customer's house. I just don't like doing it like that, but that's my personal opinion. If I noticed that, I'll be honest with you, I was on not Facebook. I was on yes, I was. I was on Facebook Marketplace, and one of the technicians was retiring, and he was selling his oven dolly for $100, which is cheap. So have the right tools for what you're using. Okay. Once again, this is the same bottom of the thing with our heating elements. You notice that it is a little Kringlish, which is Korean and English, which it's not heat. They don't spell heating right. Okay, so that is your basic oven wiring diagrams. One of the things that you really need to know how to do is to remove the door. Okay, so removing the door, I'm going to disconnect the wiring harness. I'm going to fully open the door with pressing the lever. Okay, I'm going to pull the hinge locks downward, firmly grasp both sides of the door, close the door to the removal position, which is it's where that stop is. Okay, which is about 5 degrees. Lift the door up and out until the hinge arm clears the slot. I will tell you that the first time that you do this, it is difficult. Okay. So the first time that you do this, it is very difficult to get it all right. This is a picture diagram because it's always easier to look at a picture. So if you look, here's where they're at the very top right over there. That's where they're disconnecting that connector. If you look at the center picture, see them folding the unit down so that it will you can remove the door. Then after I've got it all the way down, is the picture. I can go to the I can go to this 5 degree position. It will lock. I can lift up and up and down. I'm going to tell you, the first time you do it, it is very difficult. And the problem is, I had a class on an oven. The technician was messing around with the door, and the flipped it over, and then whenever they flip the switch on the hinge, it really made it very difficult to get it back in like it was. Okay, so one of the things that used to drive me crazy as a technician, the first time you ever do this also, is how do I get the handle or the glass out of the door? Okay, so we're going to go through. The first thing you're going to have to do is remove the handle. Okay, so to remove the door, you have to go through the process and you remove the door from the oven. I'm going to place the oven door on a padded work surface with the front glass facing down. Okay, I'm going to remove the 3 bottom screws from the door. Then I'm going to remove the 2 handle screws from the door. I can separate the door by lifting the rear door assembly off of the front door assembly, and then I'm going to set that aside. Once again, they make a point of saying to put it on a padded work surface. You have to make sure that whenever you separate this door, that you're also putting that on the padded work surface. Okay, so here it is in the easy to do option. You notice there's 3 screws across the bottom of the door. Then there's the 2 screws for the handle. Once you remove that, you're going to remove the inner door, which is right here. Okay. Now you're going to have to remove the handle, and then once you get the handle off, you can remove that inner panel. Once you get that inner panel off, this is what it looks like. Okay, then I can take this off. I will. I'm sorry. So then I come to this, and I can replace the inner glass portion. So it all comes in one piece. You set it back together, and then you're going to have to put it back together, you just reverse what you've already done. Okay. Just to remove the door handle, I remove the 2 rubber pads and the 4 screws, remove the 3 screws to remove the door handle. Once again, here you go again. So you're going to remove those 3 screws. You're going to remove those screws at the door handle, and then I can take the handle right off. Okay. There it is right there. Okay. To remove the inner glass, like I've said, you remove the 4 screws, the glass inner sub assembly. We're going to remove the 4 screws to remove the LED assembly and the 2 sub glasses. Okay. I'm going to remove 10 screws to remove the baffle door, and I'm going to take the inner glass assembly apart. Okay. Here's pictures of this. So you take, whenever we got back, we've gone back now, and we're talking about how to get the inner glass out. So I'm going to take out these 4 screws. Once I get those 4 screws removed, I can remove that piece. Then I've got 2, 4, 6, 8. You've got to remove all of these screws. Once I remove all of those screws, I've got right here, I'm going to have to remove that. And then that gives me the inner glass that I can just take out. Okay. So removing the door gasket itself, when it's the only problem that you have removing the door gasket, okay, is going ahead and getting the little clips to come in to be. First, you have to take the door gasket off, and then you have to put it back. A lot of the times, whenever you go to take it off, one of the clips will hang, and you spend 5 minutes trying to get that one little clip out. Putting it back together is not that big of a deal. You just push it in, and it's okay. But what am I going to do? I'm going to open the door oven to its fully down position, put the ends of the gasket out of pull the ends of the gasket out of the door, the liner holes. Okay. I'm going to pull the door gasket clips out of the holes until the clips are removed. So this is where I was talking about. Sometimes it's very difficult to get that clip out. Okay. When you install the new gasket, this is an important thing to remember. Okay. Make sure that all of the clips are seated in their liner holes and that the ends of the gasket are pushed fully into their holes. Use the pointed end of a pencil to push the gasket into the holes. I would tell you, do not use a pointed pencil. Use a scratch awl. Okay. That's what the factory says. And I would tell you, use a scratch awl, not a pointed end of a pencil. Pointed end of a pencil tends to break, and then I have to resharpen it. So here it is in picture form. Okay. Shows you the whenever I've got the door removed. Now I'm just going to pull the gasket like it's showing right here. This is where I'm talking about if the gasket's really old. If you look at this clip, this clip may, I'm looking at the gasket itself. At this point, it looks like the clip might have pulled through, and I've got to get a pair of needle nose pliers and get that clip out. So there's what it looks like when you remove it. Okay. Now, whenever you go and you put it back in, you have to remember that you have to seat it all the way in. If you don't, you're going to be back out fixing it or replacing everything. Okay. So one of the things about a Samsung is they have a Wi-Fi module. So how do I replace the Wi-Fi module? I'm going to turn off the electrical supply. I'm going to remove the cover, and then I'm going to disconnect the wiring harness, pull off the Wi-Fi module, and then I'll remove the connector. It's easy. Here's the Wi-Fi module right here. So it's very easy to remove it once you get into the unit itself. Okay, removing the steam set. Okay, this is a fun project the first time you ever do it. Okay, turn the electrical supply off. Let's just stop right here. Okay, if I'm going to be doing anything besides checking voltage, and I'm still going to, I'll be honest with you, the first thing I'm going to do once I get the oven and I set it on a cart, and I'm going to take the screws off, I always turn the power off to begin with. Okay, so I go to the box, I find my oven switch. We all know that it's a 220 volt switch, so that narrows down a whole lot of the where I'm going to try to find where it is, because it's a double throw. It's a double throw switch because it's 240 volts. So usually that's not a whole lot. Usually there's an air conditioner in it and a dryer and your oven in the panel itself. So that I'm going to there may be other ones depending on the house. Okay, some houses that I've been on had washers and dryers on the first, second, and third floors. You know, so I get a few more things. 9 times out of 10, it's not labeled, so you don't know really where it belongs. But usually there's only 3 or 4, and if something happens and I flip the wrong switch, I can't use the dryer, and I can't. The air conditioner won't work. But I always flip it off, and then once I find the right one, I make a little label, or I put a little arrow on the panel itself to show me where the oven is. Okay, so that's what I do if I'm going to have to do anything to the oven itself with the electrical. Okay, once I'm going in there and I'm taking the screws off, I'm going to make sure that I don't drop a screw in the oven, or I'm gonna accidentally hit something and now shorted the oven, and now I have to buy a board. Don't want to do that. Okay, so I'm going to pull the oven away from the wall so that you can access the upper panel. I'm going to remove the upper panel that we're talking about. Remove the 2 screws from the upper left corner and the right corner. I'm going to remove 3 screws from the upper cover. Then I'm also going to disconnect the wiring harness. Going to remove the 3 screws and the hose connector. Okay, this is for the steam set. Here's what it looks like. Here's what they're talking about taking the screws off. This is the diagram. I'm sorry it didn't get any bigger than that. Okay, here's the where you're pulling the hose off. Here are the screws that they're talking about that you have to remove. There's if you notice, this is a pinch clamp, so you're going to have to use a pinch clamp to get it off. Okay, so here is actually exactly how the water flows. So you can tell the water flow through here. So if you have any questions, you can always resort to this later on. Right now, you're probably not gonna need it, but if you get out there, this will tell you if you don't know where it's at. Okay. So once I remove all of that, here's what it comes to. You can see the water tank. You can see the water pump, the drain pump, the upper oven hybrid cleanup pump, and then the lower oven hybrid cleanup pump. Okay. Here's the cavity where it goes through. You see the two things in the steam generator here. This is the hose that you have to remove. Okay. So I'm going to remove the steam tube, remove the two connectors, the tube clamps. I'm going to remove the 3 screws, going to pull the 2 TCOs forward and separate. Here's the pictures of that. Okay. Then my steamer assembly, once I remove all the screws, this is the way that this steamer assembly looks. My assembly generator subassembly, I'm going to remove the connector. I'm going to remove the 2 holder tubes and then the 2 screws. And here's the picture of this. Okay. Here's the connector that you have to unplug that I was talking about. There's 4 screws right here that we were talking about. Okay, now we come to my favorite part of the presentation. Okay, what happens if I get failure codes? You usually will not find these except in a technical manual. They don't have failure codes for the consumer to look at. If you've got them, don't give them to a customer, because the problem is the customer thinks they are an appliance technician, and now they have actually run the risk of hurting themselves because it's 240 volts. Okay. If I have a CDO, okay, it occurs whenever the keys are shorted. Okay. So I have the keypad assembly that I have to look at. Okay. I'm going to check to see the keypad cable is inserted in the corrector and the subassembly. Okay. I'm going to check the shorts between the sub PCB and the connector or the keypad and the cable. If no faults found with the subassembly connector and the keypad cable, you have to replace the PCB. Okay. I will tell you this: before I condemn a PCB, the first thing that I do is I take a pencil that has an eraser on it, and I clean that cable and reinsert it back into it, and then I check it again. A lot of the times you can just clean it and your problem will go away. Okay. If I do all that and I still have this C-DO code, I'm going to have to replace that PCB. Okay. If I have a C-D1, okay, the code says that the door lock is mispositioned. So now I have to go back. I have to disconnect the power. Okay. I'm going to make sure that I have power to the connector so that I haven't thrown the code because I have a short. Okay. Then I'm going to confirm resistance with the value of the door lock. Okay. Normal value should be 1600 to 2200 ohms at room temperature. Okay, so whenever I do this, I'm going to operate the door lock assembly. I'm going to measure the voltage at the plug supplying the power to the door lock, and of course my normal voltage there is 120 volts AC. Okay, I'm going to check where the door is locking and the switch is working properly. One of the things that you will find a lot of times is that I can realign the door locking mechanism itself, and I can get it to work properly. Okay. Before I go and I go and try to have to replace everything, I'm going to try to, if I see that it's actually working, trying to pull it in, that tells me that my C-D1 error code is not right. All I got to do is realign the switch. Okay. If I have a C-FO, this code tells me that the communication between the main board and the sub PCB has been interrupted. Okay. Why would I have this problem? Why would I have this? Power failure. Okay. If I have a C-FO, that tells me that I may have I may have had a power failure, and that could be my problem. I'm gonna take it out, take the code out, and then I'm gonna check it again and see if I get that CFO. If I do, I'm going to check whether the connection on the main PCB is the little ribbon cable is correct and it's inserted right. I'm going to check where the other thing I can check is whether the connector on the PCB has been inserted right. You'll find this if somebody's been out working on it, or if the customer's been out and they thought they knew what they were doing and they misaligned the connector itself. So if there's no issue with the connector, the main PCB and the PCB sub PCB have been disconnected, I'll replace the main PCB. Okay. So I'm going to stop right there, and I'm going to ask you if you have any questions. So does anybody have any questions so far on this first failure codes? Okay, I don't see any. Doesn't look like anybody has any questions. So we're going to go back and we're going to start back. Okay. All right. Okay. If I have a CF2, this occurs when the communication between the main PCB and the touch PCB is interrupted. Once again, could be that there's a power failure, so I'm going to check that. Okay, I'm going to ask the customer, when's the last time you lost power? Or if you did like I did and you're flipping breakers, you could have caused this error. All right, so I'm going to check the connector for the sub PCB. Okay, if there's no issue with the connector, I'm going to replace this sub PCB. If the problem has not been solved after replacing the sub PCB, I'm going to replace the control PCB. Okay, so if I get a CF2 failure code and I make sure that I have the connectors are good, I'm probably, as a technician, I'm probably going to replace both PCB, the sub PCB, and the control PCB, or I'm going to at least order both of them. If a lot of the times, once you order it, if it's an electronic part like this, they will not take it back unless you have a good relationship with your parts distributor. So you want to make sure that I've got the part and I don't have to come out twice, because if I have to go out 3 times, I'm losing money hand over fist. Okay, so I'm going to order them both. All right, if I have a C-20 failure code, the oven sensor is open. Okay, so if the oven sensor is open, that's when the oven's operating. Okay, I'm going to check the connector at the main PCB. Once I do that, I'm going to check whether the connector at the sensor, where the connectors are for the sensor. Going to make sure that those are right. If those are good, the connectors are good. Okay, I'm going to replace the temperature sensor. If I still have a problem, usually 99, I'm going to say 99 times out of 10, that fixes it. The first thing you're going to do is you're going to check your sensor, because, like I said, you should be able to look at your sensor ohms, and it should tell you your resistance that you should have whenever it's at certain temperatures. If those are within those scales, I'm not going to have to replace the sensor. I'm going to have to replace the main PCB. Okay, you guys, you're going to have to pardon me. I just apologize that I have a really bad allergic reaction to one of the native plants here in Alabama, called goldenrod. So it makes me really stopped up, and I can't really breathe well. So if I have a C21, okay, this code occurs, internal temperature rises abnormally high. Okay, what am I going to do? I'm going to disconnect the power. I'm going to check the sensor harness. Okay, I'm going to measure the sensor resistance right here. Like I said, there's a chart, and it should tell you at room temperature this sensor should read 1080. If there's any problems, replace the sensor. Okay, if that's not my problem, if I'm in within tolerance, I'm going to check the resistance of the broil and the bake convection heaters. If that's not the problem, I'm going to check whether the DBL, the main bake, broil, and convection relays on the PCB are working normally. You can literally hear those connectors pull in. Okay. Then I'm going to check whether disconnected. Check the resistance of the oven sensor connector on the main PCB. Just going to normally at the PCB, you should read 2850 ohms, and that's on the sensor connector. Okay. The unit will display C21 after beeping 10 times if the temperature is higher than the specific specified as it is when it's specified during operation. Okay, so we're just going to go back to steps 4-1 on the other one that we had on how to check it. All right, so CF2, this occurs if the communication between the main PCB and the Dutch PCB is interrupted. I'm going to check the connector on the sub PCB. Okay, C20. Oh, I'm sorry. For some reason it reverted back to the other one. Okay, interesting. Okay, so if I have a C30, it tells me that the PCB temperature sensor is open, and I'm going to have to replace the sensor. If I get the other one could also be that it is whenever I'm trying to operate it. If I get a C30, could tell me that the PCB is oven sensor is shorted whenever it's being operated. So it could be open or shorted. So you're going to have to pull it out. You're going to have to go back. You're going to have to read. You're going to have to read your sensor ohms. And like it said, at room temperature, it should be 1080. If I'm checking it from the sensor itself, if I'm checking it on the board, it's 2840. I think is what it was. Okay. If I get a C31 error, it occurs when the PCB temperature rises abnormally high. Okay. So I'm going to disconnect the power, open the back cover, and then I'm going to have to replace the main PCB. Okay. If I get a DC error code, it tells me that this is the partition inserted or removed while the unit oven was operated. Okay. So all you do is you go and make sure that that you insert the partition properly and reset the oven. If that doesn't take care of it, I'm going to disconnect the power. Then I'm going to reconnect the power. If that doesn't take care of the problem, I'm going to have to replace the PCB. Okay. If I get a C70, the steam connector is open when the steam mode is on. That's going to check whether the connector on the main PCB has been inserted. Check the connector at the main sensor, make sure that it is in proper. If the connector of the main PCB and the sensor are inserted correctly, replace temperature sensor. If the problem still persists, replace the main PCB. That's for a C70 error. These are all error codes that you really need to know. And if you don't have the manual for this, which is why we do this program, you can revert back to this program and you will have these error codes and you will know what they mean. Okay. C72, the drain system related problem occurs when the water level sensor remaining from the main maximum time of the drain time. In my experience, I have seen the C72 more than the C70. Okay. So what am I going to do? I'm going to check the ground wire on the steam generator. Then I'm going to check the pump motor to make sure, and the wiring harness to make sure that they are connected properly. If it's still not fixed, I'm going to have to replace the main PCB. Okay. If I have a CA2, our cooling motor operation is not working properly. So it tells me that I'm either going to have a main connector PCB is not the connection is not proper. And it could also be that the motor connector is not proper. Okay. If I have a CA2 and all of those connections are good, means I've got a bad cooling motor itself. Okay. So here are the part numbers for all of these. Like I said, this is what I like about Samsung. They give me part numbers. Okay. So if I have the oven not working, no power to the display, first thing I'm gonna do is check the voltage to the oven itself. Okay. Make sure that I get my 240 volts. Okay. Going to have to measure the supplied voltage to the connector on the main PCB. I get L1 to neutral, should get 120 volts. If I go to L2 in neutral, I should get 120 volts. Then if I go between L1 and L2, I should get 240 volts. Okay. If something happens and I don't have those, I've got a bad cable connector, and I'm going to have to replace. I have seen where at the factory, whenever they were inserting it into the cable itself, that they nicked the wire, and that I had to replace it. Those will drive you crazy. The oven. So again, the oven's not working properly. I'm going to make sure that the relay on the sub PCB is working normally. I'm going to check whether the connector between the sub PCB, the wall main PCB, and the new FM PCB are loose or disconnected. I'm going to tighten all those up. If something happens and nothing fix it, I'm going to replace the sub PCB relay. It's probably damaged. So that sub PCB relay may have a crack in it, so you can visually inspect. Some of the times you can't, but you can go and check from the back side. If you get the board and hold the board out, you can check where it goes through just to make sure that there wasn't cracked or damaged. The repair harness connecting to the main PC, the main board, and the FM and the sub PCB I'm going to check all of those, make sure those are good. Make sure that the wiring harness connected to the relay on the sub PCB. None of those is bad. I'm going to check my voltage coming from my main board to my sub pub CB, my FM board, and my sub PCB. If I've got voltages through if I don't have voltages there, I'm going to have to replace the I'm going to have to replace the main PCB. If I've got voltages to each of those and it's not pulling in, I'm going to have to look at the main PCB and the sub PCB, determine which one is bad. I'm going to check power in, power out. If I got power in but no power out, I know that the board is bad. So I'm going to replace those. Okay. So I'm going to measure resistance of my thermostat terminals. Normally it's 0 ohms. If the thermostat's bad, I'm going to have to replace or repair the harness. I would tell you to replace it. Replace if I have power to it, okay, to the thermostat, I am then going to have to I'm going to have to do something to the PCB. Okay. So I'm going to check the harness to make sure that I don't have any terminal looses or the terminal is not loose or disconnected. I'm going to measure the voltage on the main PCB. You look right here on IC102. I'm sorry, IC02. I should read 12 volts DC. And if I have IC03, I should get 705 volts. Then that's a 5 volt DC. Okay. So once again, I can go through right here. This is just a basic step diagram. So if I have no power, I'm going to check the terminal block voltage. If I have no terminal block voltage, I've got to go to the circuit breaker, or I'm going to, it could be something in the terminal block and it's shorted. If I have the right voltage, I'm going to check the wiring. If I still have the right voltage, I'm going to check the input. Okay. So the voltage on the PCB is 120 volts. The output is 12 volts or 5 volts DC. If it's defective, I'm going to replace the PCB. Okay. So once again, if I want to troubleshoot the PCB failure, step diagram, step by step by step. That's all I'm going to worry about. Okay. So I'm going to check the input voltage of the PCB. Should be 120 volts. If I don't have that, I'm going to check the terminal block. Okay. If that's bad, then if I have the terminal block voltage, I'm going to repair the faulty wire or the PCB. If I don't have it, I'm going to replace the circuit breaker or the checkpoint. Okay, the module. Okay, for the main power. So if I have all of that, I'm going to check the output voltage of the PCB. Okay, if I have that, I'm gonna just step down and then I'm gonna check the relay. Okay, if I don't have the voltage to the PCB, I'm sorry. If I check the voltage of the PCB and I don't have it, I'm going to replace the PCB. Okay. If I do have it, okay, I'm gonna look at the relays. If the relays work properly, I'm gonna check the PCB voltage output. Right here, it shows you that it's 12 volts. Okay, that's between that's your 5 and 12, and then you're going to go between those and ground. If I've got that, then I'm going to replace the PCB. Now, if I go to the relay and I don't have it, I'm going to have to either replace the relay or the main PCB. If the relays operate properly and I check the voltage, if I don't have that, I'm going to have to repair or replace the wiring. Okay. I will tell you that this step right here, you end up probably going to end up having to replace the Wi-Fi board. Okay, we went through how to replace the Wi-Fi board, so we'll just do some checks to check the troubleshooting on it. Okay, we'll see if we have the display and you got the Wi-Fi signal. Okay, if the display on the icon, check the Samsung Smart Home app. If I've got that, then I can delete and reinstall the app and try it again. If it does not show the icon, I'm going to have to do the home network, make sure that it's actually sending power. The oven itself can find the power. If it does not show the icon, check the home network. If the network is okay, I'm gonna follow step 2. If the home network has a problem, you have to contact the service. Okay. So step 2 is I'm going to check the communication between the module and the sub PCB. Okay. I'm going to press the settings and the lamp at the same time. The display will show PJT, main control PCB version, sub PCB version, and the network version. Okay. If the network version shows normally, try to use the smart module control feature again. If the network version is missing, check the Wi-Fi module, which is step B2. Okay. So I'm going to remove the Wi-Fi module. If I don't get it, I'm going to remove the Wi-Fi module. Okay. We've already been through on how to remove the Wi-Fi module. I'm going to check the voltage on the Wi-Fi module. If I get the input voltage is good, I'm going to have to replace the Wi-Fi module. If the information is not present and is not present, I'm going to check the harness, the PCB connector, and the PCB, the sub PCB. Here are your connectors right here. You look at the number 1, number 2, 3, 4, 5, and then the reset. It's showing you right there where those are located. Okay, give me just 1 second. Let me take a quick look right here. Okay. All right, remove the top cover. Okay, see the page 3.3, removing the main PCB to do that. If the connection of the wire is okay, check the next step, which is D. So that's remove the sub PCB. Shows you how to do that. Check if the wiring harness connector is fully and correctly inserted. Then check the input voltage on the sub PCB, which is 5 volts. Pin 1 is ground. Pin 4 is the 5-volt DC. If the voltage is okay, I'm going to replace the Wi-Fi module. If the input voltage is not present, I have to replace the sub PCB. Okay, so talking about pin 1 and pin 4, we're going to go back. Look right here. Pin 1 again is ground. We show that. And then pin 4 we're showing is 5 volts. So I'm going to go between pin 1 and pin 4, and I should read the 5. Okay. So if I have a problem with the micro switch and the motor after removing the wiring harness from the terminals, check to make sure that it actually locks properly by pressing the control lock for 3 seconds. If the if something happens and it still doesn't lock, I'm gonna check the resistance on the motor. I should have between 1,600 and 2,200 ohms at room temperature. This is 120 volts AC. This is not a DC voltage. Okay. My micro switch, my normal to common, should be closed when the door is unlocked. So I'm now going to go between common and normal and see if it's closed or if it's open. If something happens that I've got everything and it's working, it means that I have a problem with a connector. Okay. If these aren't good, then I'm going to have to replace the module. Okay. Measure the side of the partition after taking off the harness. This shows it right here. My resistance is 1750 to 1850 ohms. If something happens, I may to either to repair or replace the harness if it's been loosened or disconnected. Okay. Once again, here's the lower convection fan. Fans work exactly the same. It's 120 volts DC. If I've unplugged it, I should read somewhere between 20 and 30 ohms. If I don't get my 20 to 30 ohms, I'm going to have to replace the convection fan. Okay. Replace or repair the main PCB of the oven. The main PCB is the upper oven, and then the lower oven is for your new FM PCB. Okay. Once again, these are simple, basic for your broil heater and your bake heater. This is how you check them. Again, if I measure the resistance for the heater terminals, so it has to be off, and I have to disconnect the wires. Okay, I'm going to measure the voltage of the heater terminals after selecting broil. This is after I've measured the resistance. If I get the proper resistance to the element, and the element is checking okay, then I'm going to plug these back in. I'm going to turn the power back on. I'm going to measure the voltage of my heater terminals whenever I select the broil in the element. Okay. I'm going to repair the main piece. I'm going to have to either the terminal voltage is 240 volts. So I'm either going to have a bad PCB. I actually suspect that this is the problem with my dad's lower oven, is that I have a bad PCB for my upper. So it's his is the lower. So his doesn't have this FM PCB. Just the all he has is the oven, an upper and a lower PCB. So this is how you do the broil, the bake, same thing. Okay, I'm going to measure the resistance of the heater. I unplug it. I measure the resistance of the heater. I should get between 18 and 21 ohms at room temperature. Once I do all that, I'm going to hook it all back together, and then I'm going to check the voltage to the heater itself, and I should have 240 volts. Okay. If something happens and I don't have bake or broil, and I don't have any voltage going to that heater, the one thing that you have to remember is on a oven that has self-clean, you will have to rule out that your L2 is good because your high limit thermostat. If your high limit thermostat is blown, I'm only going to get 120 volts between the L1 and normal. I mean L1 and ground. Okay. If I've got that, then I don't. If I don't have the other, I have a blown high limit thermostat. Okay. So my connector, my convection heater, once again, I'm going to go and I'm going to unplug it. I'm going to turn it off on the breaker. Then I'm going to measure my resistance, see if I've got between 40 and 46 ohms at room temperature. If it works, I'm going to go back and I'm going to plug it all back in. Once I do that, I can check to make sure that I've got 240 volts. If I don't have 240 volts, I'm going to have to go to the PCB and make sure that coming out of the board itself that I have 240 volts. If I've got it, then I know that I have a bad wire. If I don't have 240 volts, I'm going to have to replace the main PCB of like the upper oven is the wall main PCB, and if it's the lower oven that I have the problem with, I'm going to have to replace this new main PCB. Okay, so our steam heater, how do I replace the steam heater? I'm going to measure the resistance of the value at the heater terminals. I should have between 26 and 30 ohms. Okay, at that point, I can now plug it all back together, flip the switch. The terminal voltage of the drawer heater is 120 volts. If I don't have the voltage coming through the wire, I have to check the wire to make sure that the wires are good. If the wires are good, I'm going to have to replace the main PCB. Okay, guys, we ran over. We're not bad over. We're actually at 8 minutes. Does anybody have any questions right now? How do you check the relays? Okay. Giuseppe, right? You're going to actually on the C21. Okay. How do I check that? I'm going to have to go to the back of the board and check it on the back of the board. So I'm going to go back over here. Okay. I'm going to open this back up. Okay. So this is the front of the board. Okay. If you remove that, there's two little clips that hold that board in, or it could be a screw. I don't remember now. But I disconnect that, and I can go to that and check the back side to see that I have the relay pulling in. Okay. Did that answer your question?